Welcome back. Did you know that log of 1 to whatever base is equal to 0? You should know this concept. Log 1 is equal to 0, whatever the base it is. For example, you have log 1 base 2 is equal to x. This one is coming from the concept that we learned earlier about writing from index to logarithmic or logarithmic to index notation. Let's try writing this to index notation and find the value of x and see whether it is going to give us 0. So we shall have 2 raised to power x should be equal to 1. We are going to write 1 to base 2. 1 to base 2. A number raised to power 0 is equal to 1. So therefore, we are going to have 2 raised to power x. 2 raised to power x is equal to 2 raised to power 0. Why? Because a number raised to power 0 is equal to 1. Any number raised to power 0 is equal to 1. So in this case, we are able to see that x is equal to 0. And now this is in agreement that log of 1 to whatever base, log of 1 to whatever base is equal to 0. The next, log to base 3 of 1 is equal to y. What is the value of y? So we start by writing this to index notation. We shall have 3 raised to power y is equal to 1. Now in this case, we are going to convert 1 to base 3. So we shall have 3 raised to power y is equal to 3 raised to power 0. Why? A number raised to power 0 is equivalent to 1. Now in this case, y is equal to 0. The next, log of 1 base 5 is equal to a. What is a? Automatically you should be able to know that a is equal to 0 because log of 1 to whatever base is equal to 0. But let us confirm that it is true. 5 raised to power a is equal to 1. Convert 1 to base 5. So we shall have 5 raised to power a is equal to 5 raised to power 0. Why? A number raised to power 0 is equal to 1. So therefore, in this case, a is equal to 0. And now the last one, I want to believe that you are able to do. Kindly find the value of x in this other one. Log to base 8 of 1 is equal to x. What is x? Now, another rule that you also need to know is log of a base a is equal to 1. Log of a base a is equal to 1, and we'll explain how this concept is coming about. This is also coming from the concept that writing from index logarithmic notation to index notation. In this case, if you write a to power 1 is equal to a, we say that this is the base, you raise it to the index and then equivalent to the result. So therefore log we shall have a raised to power 1 is equal to a. In this case, this other a on the right side do not have the power, but you are able to see that in this case a raised to power 1 is equal to a raised to power 1. They are equivalent, and that is how log of a when the base is a is equal to 1. So kindly understand this concept. Log of 2 when the base is 2 should also be equivalent to 1. I'll give another example. Log of 10 when the base is 10 should still be equal to 1. So long as the bases are the same, the log of a number equivalent to the base of that particular logarithm, that one will always give you 1. I want you to confirm using your calculator what is the log of 10 should give you 1. Now in this case, the base is not given, but you should understand that whenever the base is not given, we are talking about base 10. So in a similar way, as I finalize this concept of log of a base a is equal to 1, you should also confirm that it is true that log of 8 base 8 should still give you 1. Why? Because if we write this in index notation, it is true that 8 raised to power 1 is equal to 8. 8 raised to power 1 is equal to 8. That is where that concept is coming from. Then the last that I want you to also understand is this. Log of b raised to power n is equal to n log b. Log b raised to power n should be equivalent to n log b, or the other way around, n log b should be equal to log b raised to power n. know how to play around with this kind of situation. This is another basic information about logarithm that you need to understand. Let me give a good example. If you have log 10 squared, this one you can write this as 2 log 10. Another example, log 2 power 3 can be written as 3 log 2. Or if somebody gives you 2 log 4, you can write this as log 4 squared, which you can simplify to give you log 16. So now be ready to apply this concept, because some situations will always be require you to understand how to play around with this kind of concept. Log b power n is equivalent to n log b. Now, in the following examples, we are going to apply those particular concepts. We talked about this particular concept. The first one that we started with is understanding that log of 1 to whatever base is equal to 0. And then we also understood that log of a when the base is a is equivalent to 1. And then the third one is that log of b raised to power n is equal to n log b. It will assist us to simplify logarithm. Like the way we are now moving to this particular concept, we are told simplify the following. We are told simplify log to base 2 of 32. So in this case, we are going to express 32 to base 2. So we shall have log to base 2, 32 becomes 2 raised to power 5. So in this case, we are going to bring down the power 5. So we shall have 5 log 2 base 2. And then look at this part. We just said that log of a base a is equivalent to 1. Log of a base a is equivalent to 1. So we are seeing that situation here, and we're going to use that concept to simplify nicely. So we know that log of a when the base is a is equivalent to 1. So in a similar case, a can be any number. Like in this case, it is log of 2 base 2. That should be equivalent to 1. So in this case, we shall now have 5 into 1 is equal to 5. So this one will simplify to become 5. And where is this coming from? Because log of 2 when the base is 2 is equivalent to 1. That is coming from this concept that log of a base a is equal to 1. So we shall be, it's like saying 5 times log of 2 base 2, and log of 2 base 2 is equal to 1. So therefore 5 times 1 to give you 5. The next example is here. Log to base 3 of 84. So we shall write 81 log to base 3 of 84 of 81, log to base 3 of 81. We are going to write 81 to base 3. We shall have log to base 3 of 3 power 4. Then we are going to drop this power 4. We shall have that this one is equivalent to 4 log 3 base 3. And we know that log of a when the base is a is equivalent to 1. So this one will be equivalent to 4 by log 3 base 3 is equal to 1. So this one will now give us that the final answer is equal to 4. Final answer gives us 4. Correct. The next is 1024 and the base is 4. So we are going to express 1024 to base 4 log to base 4. 1024 is same as 4 raised to power 5. So this one will give us 5 log 4 base 4. And log 4 base 4 is equivalent to 1. So this one will give us 5 by 1. And this one simply becomes 5. Now, what about this? Log to base 2 of 1 over 56. 256. So we shall have log to base 2 log to base 2 1 over 256. 256 is same as 2 raised to power 8. Yes, 2 raised to power 8. So log of 1 over 2 raised to power 8. And this one is same as log to base 2 of 2 raised to power negative 8. Then we're going to drop this power negative 8. It becomes negative 8 log 2 base 2. It will become negative 8 log 2 negative 8 log 2 base 2. And we know that log of 2 when the base is 2 is equal to 1. So therefore this one will be negative 8 multiplied by 1 to give us negative 8, and that becomes the correct answer for that case. So I want you to try this one. Log 2 base 3 of 243. What will become of that? Simplify this other one. Log 2 base 5 of 625. What will become of that? Then we have log 2 base 7 of 343. We are looking at laws of logarithm, and we have three main laws of logarithm. Law number 1, product or multiplication law. And we're saying that if you have log A plus log B, this one is same as multiplying A and B. So we shall have this to be equal to log A times B. Examples, we are told to simplify the following. Log x plus log 12. We shall have this is equivalent to log of x times 12. So x times 12 is equal to 12x. So that is how it can be simplified. Example 2, log 20 plus log 5. So this one is going to be equal to log 20 by 5. And 20 by 5 is same as log 100. And we say that when the logs are not given to a given base, then that is natural logarithm to base 10. So therefore this is same as log 100 base 10. Convert 100 to base 10. So this will be same as log 100 same as 10 squared base 10. And this one is going to be equal to 2 log 10 base 10. And log 10 base 10 is equal to 1. So therefore it becomes 2 by 1 to give you 2 as the final answer. This other one we could not continue with it because we have an unknown. So therefore it can only be simplified up to that level. But for log 100, 100 can still be simplified further using the previous basic concept that we learned earlier. Now, let us look at the second law. It is called the quotient or division law. And here we are saying that log A minus log B is equivalent to log A over B. So when logarithms are subtracted, you divide the values of the logarithms. Examples, simplify log 16 minus log 2. So in this case, we are going to have this to be log of 16 divided by 2. And we simplify this. 16 divided by 2 is same as 8, so it becomes log 8. That becomes the simplified format of that. The next, log 12 minus log 3. This one becomes log 12 divided by 3, and this becomes log 4. Then this is log 30 minus log 10. This becomes log 30 over 10, and this becomes log 3. So we are told to simplify. In this case, log 4, log 8, and log 3 cannot be simplified further because you are not able to express 3 to base 10. Even though these are logs to base 10, you cannot be able to express 3 to base 10. Then the last one is called change of base. This one can be written as, you can change the base. It now becomes 1 over log A base B. So when you want to now move this value to become the base, then you're going to put everything as a reciprocal. So it becomes 1 over log A base B. This is the law. We call this the change of base. For example, we have log 2. We can write this log 2, log 2 base 2 of 4. We can write this, and this one will become log of 4 base 2 will now become 1 over log 2 base 4. 1 over log 2 base 4. Then the next log 9 base 3, this one will now become 1 over log 3 base 9. 1 over log 3 base 9. Then the next is log 12 base x. This will now become 1 over log x base 12. And these rules can really help you later when you want to simplify where the bases are not the same, but you are able to express all of them to a given base. So you are able now to change from one base to another base to make you be able to simplify. So bye for now. We are going to continue later. Have a good day and good time. Bye.